Greetings. In 1982, there was a war. There was a war in the entertainment industry because the reigning king of amusement machines, pinball machines, was being seriously threatened by video games. Pinballs weren't doing too well. Videos were doing well, but in '82, none of them were doing really well. So Bally Manufacturing, for one, decided, why not combine the two? Let's make friends, and that way we can capture the market. So they came up with Baby Pac-Man. Now, Baby Pac-Man was a combination of video and pinball. So what happened here, they built an arcade cabinet, even though it was unconventional in its form, that housed a pinball playfield over here, which was about a third the size of regular pinball playfields at the time, and they stuck a 13-inch monitor in here that played a version of Pac-Man. And the way it worked was you got started playing pinball, and if you completed the right things, then the ball would be held and you would be sent up to play pinball. The flipper buttons were on the panel here, and the joystick in the middle was for playing Pac-Man. And then, of course, you played Pac-Man, and then if you lost, then the ball got kicked out again in the pinball playfield, and you know that was the game. But some of its downsides were, well, let's say the positive thing first. It was brand new. It looked like a really good idea, but my personal opinion is that it wasn't implemented that well for several reasons. The pinball playfield was too small. It was like a toy. There really wasn't a whole lot of skill required to do anything on there. And second of all, the video game was on a 13-inch monitor, and it wasn't really implemented very well. And that is not so much the fault of the hardware. It used the Texas Instruments 9928 VDP, a video display processor, and that chip was also used in the ColecoVision game console. And they did, for the time, some really good stuff with it on the ColecoVision. But Pac-Man just did not look too great. The picture doesn't really show you what's really going on here, but it was... Things were not very... They looked very simple in there. So it was neither a great joy to play pinball, nor to play video, nor to play Pac-Man in this environment. So after the originality of this thing wore off, people didn't play it too much. It did sell a respectable 7,000 units, but unfortunately it was pretty unreliable. But Bally didn't give up. They followed up with Granny And The Gators in 1984. Exact same cabinet as Baby Pac-Man. The only difference was the monitor was placed horizontally, whereas in Baby Pac-Man it was vertical. And again, small play field. They did realize that their video quality hadn't been that great on Pac-Man, so they introduced a new video board. They were still using the Texas Instruments 9928, but this time they used two of them. The game was a failure. I could not find any exact production numbers for it. It is only listed as a rare game. And that was it. Well, I just noticed this one had at least the buttons, the flipper buttons on the side, rather than plopped on the control panel. But it didn't do anything, and those were the only two machines of that era that combined video with pinball. But before we go on, let me say my thank yous. Scott Atkins donated, and also Dave Andre donated, but he is a perpetual donator. A lot of the boards you see on here come from Dave. So Scott and Dave, thank you. So what we have here is the video board that was used in Granny and the Gators. The original one in Baby Pac-Man was called the Vidiot, and then when they upgraded it and went to 2 video chips, it was called the Vidiot Deluxe. This game is this board is an unknown condition, so we're going to test it out and see if we can get an image up on a monitor. This does contain a video game that talks to the main processor through several interface pins over there. Quick walkthrough of the board is so as we get started, the interface section is over here, which talks to the main CPU board. It also has a 6821 here that I think handles some of the switch reading and mostly the communication with the main CPU. It uses a 6809 CPU to run this board, whereas the main CPU board uses a 6800. There are 6 EPROMs here that contain everything necessary to play Granny and the Gators, and of course the code to communicate with the main board. We then have the 2 video VDPs over here. Each one has 16K of DRAM accessible to it. This section is what mixes the outputs of these 2 chips together, and of course lets you adjust all the video parameters. I did used to own a Granny and the Gators a long time ago, and I remember that it wasn't trivial to get a good video output, because turning these pots, everything affected everything else. So you set something up right and it would look great, but the rest of the stuff didn't look too good. So it would take several passes to go through this. And the problem is I never found an official video adjustment guide that would tell you, hey, the usual stuff, turn everything to the center and then start turning this pot till this happens. And I never found one of those guides. So it's probably going to be hit and miss. Well, not hit and miss, but it's going to be difficult to get any video out of this, any sensible video out of this, if of course this works, or we can get it to work. The final part is power regulation. It uses a single 12-volt, unregulated 12-volt input, and from that it generates 2 5-volt rails with 3 amp regulators on it, so it needed a lot of juice to run everything. And then it also has an 8-volt regulator over here that runs all of the op amps in the analog mixing section for the video. So yeah, there's quite a few things that could possibly go wrong. But yeah, let's have a look. Now the one thing, obviously this is all I have. I don't have the whole machine. Nobody's talking to this machine. I mean, no other PCBs are talking to it. So, when you're doing a standalone board like this and you're not getting it to work or anything out of it, there's always the risk that it's actually working, but some of the peripheral stuff required isn't there, so you can't get anything out of it. So I've done my research on that, and yes, I'm not going to be able to show you Granny and the Gators video, but it does have a video test button over here, which will put this into a video test, and I'll put some color bars or something so we can see whether it's working or not. The other aid we have, and you've seen this in other Bally boards, is there's a green status LED over here that will blink several times as the processor boots up, performing the post routine. And if all of the blinks are there, then the board's running. If you only get, you're supposed to get, in this case, 12 blinks. And I'll explain a little more that there's other stuff that happens here because the soundboard actually, for the game, gets connected to here. And when this thing boots up, it goes to sleep for 3 seconds and lets the soundboard boot up first. And if the soundboard says it's okay, the soundboard will blink this LED twice. And then after 3 seconds, regardless, this will start up and will give you, if everything works, a total of 12 blinks. So let's give this some power and see what happens. So we got 12 volts unregulated hooked up to it. I got it limited to 1.5 amps just in case there's something funky going on here. And as I explained before, the way it works is the soundboard is hooked up to this. So when the processor wakes up, it's just going to hang loose for 3 seconds and let the soundboard check itself. And the soundboard has access to this LED, so it should blink this twice, meaning it's okay. But regardless of the result of that, 3 seconds later, this guy takes over and starts blinking this LED by starting to running ROM checksums, memory tests, video tests. But again, it's not testing the outputs of the video. It's not wired for that, but it reads and writes to the registers here and sees if the values they've written come back. And it's a pretty thorough test with a total of 12 blinks or flashes expected. So here we go. So nothing's going to happen. Well, nothing's going to happen for 3 seconds regardless. The LED is here. And, well, here it goes. Output on. Click, click. It's not doing anything. It's drawing about 1.4 amps, but nothing. And the manual does talk about it, and it tells you what happens if the light stays on permanently or it blinks less than 12 times. But it doesn't tell you what it means when the LED doesn't blink at all. So we got to start digging. I spent some time doing the usual. It's the processor getting a clock. Is the reset signal inactive? Is the clock, of course, getting over here? Check data lines. Checking data lines is you're looking for floating lines, but you're basically looking for activity. Now on the address bus, I checked for activity. It was there. Everything looked clean, but it looked like the processor was essentially just counting up the address. Like it was turned on and executing no ops and just increasing the addresses. It sure looked like that to me because starting to measure from address 0 and then going up, I would get square waves of half the frequency of the previously lower address line. So this thing is just going bananas. So my first thought was, okay, let's do the obvious, and I put in a new processor and had the exact same results. Oh, and before I forget, I did check the voltages. I checked both 5-volt rails and the 8-volt rails that's underneath here. And I made sure that the proper voltages are getting to the chips. And they are. So next, it sounds to me like there's something wrong with the EEPROMs. So I pulled all of the EEPROMs. They're 2764s. I have a dump of the EEPROMs, and I basically put them in the EEPROM programmer, read in the reference files I had, and ran comparisons on them of the code contained in these EEPROMs versus the code I had archived many years ago, and they all checked out. Now with an EEPROM, one thing to do is, another good test is, I mean, a single compare or even several compares may not yield, even if they say it's okay, they may not yield proper results. One thing I found that yields a really good result is to continually run a checksum in the EEPROM programmer on the contents of EEPROMs. And you just keep doing that. And if the EEPROM is good, you will get the same checksum. Doesn't take that long, and you're just hammering the key. You get the same checksum 10, 20 times in a row. That's a very good indicator that the chip's not intermittent. But if even once in those 10 or 20 tries you see a different checksum show up, that means the chip is intermittent and needs to be reburned. But that wasn't the case over here. I measured and swapped chips around a little more with nothing. Couldn't get a blink out of it. And then the one thing I hadn't really checked was, I don't know why, couldn't see the forest for the tree, but there's a static RAM over here, a Motorola 6810. And if this thing went bad, that would explain the behavior. Let's say this is running a checksum and it has a counter. Well, if it's using a counter in RAM and counting down a certain number, that number is never, I mean, if RAM is bad, that number is always going to stay the same, or BFF or whatever. It's not going to hit zero, so it's just going to sit there increasing addresses forever. So that would exactly explain the behavior. So I have another 6810 here, used, but if it's in my drawers, that usually means this was tested. So we replaced that chip. Let's turn our attention back to the LED. And here we go. 12 blinks. So I guess it just woke up. Let's try that one more time. "21, 22, 23, there we go. Okay, so it's telling us that whatever the processor can test, it tested, and it liked what it saw. Doesn't tell us anything about the video output mixer over here, but in order to test that, we're going to need an RGB monitor. So let's go dig one out. Well, remember this guy? I showed him in a previous episode. It's actually a brand new 13-inch RGB monitor that got fished out of a dumpster. Fortunately, it didn't get hurt because it was still in its original packaging. So what better candidate than this to test the Vidiot? Except I turned this thing on, well, I was hooking it up. I turned it on, and I turned it a bit so I could see the screen better. And I got a bang and a flash and lots of smoke coming out of it. But fear not, it got repaired pretty expediently. Let me set up the camera to show you what happened. Well, I fixed it, but I'm not going to take it apart again. It is working. But let me briefly tell you what happened here. So when the smoke cleared, let's see if you can even see that. There's a power resistor over here. You can see the edge of it. It's a 5 watt 0.47 ohm resistor that was directly in the path of the AC being fed in. The smoke came out of it. It was blown in half with a crack through the middle of it. But you know, why would that happen? I checked around a little bit more. If that thing blew up, what else did it take with him? So what I also found, just checking, can you see that over here? No, you can't. There's a bridge over here, right here. And when I checked the bridge, one of the legs was shorted. The AC leg was shorted to the negative DC output. And of course there's a 4 amp fuse that fortunately blew. And yes, those two things would, well, the resistor's cracked, so it's never going to get any power. But if I just replaced the resistor, it would have blown the fuse again because that bridge in there is shorted. And that's fine because coincidentally I had a 0.47 5 watt power resistor in my stock, which was fortunate because it's not a very common part nowadays anymore with the disappearance of CRTs. But I guess I must have had that problem before because I had a few of them. So I replaced the resistor, I replaced the bridge, of which I had many. But before turning it on, I had to figure out why all of this happened. And after looking at it for a while, the chassis is basically held in place near the CRT with 2 hooks, one of which I am pointing at over here. These hooks fit into the chassis, one on this side and one on the other side, and then you screw it into the main frame from the back, and that holds the chassis securely in place. When taking out the chassis to fix it, I noticed that on the other side, this hook was properly inserted into the chassis. On this side, the chassis was sitting on top of this hook, and the hook was it was bent up, and that's right under the AC section here. That's right under the bridge in here. So it shorted something in the AC input and took out the limiting resistor, the bridge, and the fuse. So now that I knew what was wrong, I bent the hook back into shape, properly inserted and mounted the chassis, and we were back in business. How could this happen? I mean, this thing is in here pretty tightly. You can see the hook over there. It's not even moving. Did it come from the factory like that? Well, it was a new monitor. It was never used, so that is a possibility. Second possibility is that when it got chucked into the dumpster, it just got a shock right here. And this side of the chassis, remember, this hook was bent upwards. This side of the chassis bent the hook upwards enough for it to slip out of the hook and then come to rest on it, except the hook was right underneath the AC bridge. And it was just kind of tethering there, and it was a true time bomb. Well, actually not a time bomb, but a hair trigger bomb, which I set off right in the middle of my tests. But it's fixed, so upward and onward. And now for the big test. Monitor's on, and we're all hooked up. Let's see. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Huh. What's that? We're supposed to have a blank screen. So let's hit the video test. Something changed just in here. You can't see it because it's oversaturated. There's actually some fine black lines in here. But if I hit it again, we get color bars, but a lot of garbage. So the way this works is, I figured out that the color bars are being generated by the master processor, this guy, and the characters, this is supposed to name the colors and everything, are coming out of the slave processor. So it could be in the mixer, could be the RAM, but it is checking the RAM as part of the 12 blinks, and it did have access to the RAM. The RAM didn't bug out, so there may be something wrong with the video output circuitry in the slave VDP. So let me go dig through my stuff. I think I have one or two of them, and replace that. Well, I took some time to find the VDP, which I did. Here's the bad guy. But I did poke around a little bit more, just for grins, because everything's socketed on here. Everything except the analog mixing circuitry, which would be the next suspect, is socketed. But I did find a bad 74 LSO2, which is in the select lines to the VDPs, and also intermingles itself with signal generation in the video in the mixing section. But everything else seemed to look okay, so let's give it one more try. And here we go. I'm going to count down the blinks. 21, 22, 23, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, there's no garbage on the bottom. We did see something happening, and that's normal because it's not the main CPU of the system isn't talking to it, so it just turns off. But if we hit the video test, and there you go. So in the video test, it continually sends out signals over the interface pins, and is supposed to list that. The reason this display is messed up, and I checked it out on the internet, this is what you get when you press the test button and you don't have it hooked up to the entire system. But if you press it again, you get a correct picture, and it's actually a nice picture in real life, totally oversaturated in the camera. So I'm going to go in and turn down the intensity so you can see that actually the text is clear, but you know, I had to turn it down all the way for you to see the text. But when I turn it back on, you can see that the colors are about here. You're getting true colors out of it. And so another board fixed. And just for grins, let's do it one more time. Two, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And same thing again, we hit the button once, we get the communication stuff, and once more we get the color bars with the text overlay. Actually right now the colors for real life viewing, it's almost perfect. The magenta, red, and blue text are slightly reddish, but when I turn down the red on the mixer, it messes up everything else. So I'm going to leave it like this because it is pretty well adjusted. Here are the casualties of war. TMS 9928AN VDP, which passed the self-test, which means it was able to do almost everything, except its video outputs went bad. A 74LSO2, which just decided to give up its ghost. 6810 SRAM chip, which died. I mean, they did clean the pins, put it back in, but it made no difference. And then as a peripheral problem, which isn't really related to this board, but at least the board helped me find the problem in the monitor, which could have been worse. I could have put together a machine with a 13-inch monitor, and then that would have blown up inside a machine. This was actually the best. If it had to blow up, this was the best environment for it to blow up. It was on the bench, and it was actually relatively easy to fix. The bad bridge over here, and there's the cracked resistor, which I had to throw away outside because it was stinking up the room. I mean, that thing emitted noxious fumes. But that's it. We have a working Vidiot Deluxe board here, waiting for a Granny And The Gators machine to arrive at Artifact Electronics. And we're part of the way there, with the most complex part of the whole setup, the video board, working. Thanks for watching. Please like and subscribe and share, and follow the example of the nice people, the nice viewers who donated, and we'll see you next time.